Okay, welcome back. Hopefully this will be the last chunk of tape that we have for today's lecture. We'll see. We're actually getting away a little bit from aphasia. What we're going to talk now about just not random, but certain kind of scattered topics in brain and communication that relate to aphasia and to people with aphasia. The first one we're going to look at is something called central visual pathways. And again, you may have studied this in other courses. I know it's in your book. It has very similar diagrams. I'm going to show you different diagrams of this as well. It looks complex. It's really not. It's just a question of staying with it, okay? And I'm going to do my best to try to help you with that. What we're looking at, let's start. We have the left eye and the right eye. Okay, we're looking down. It's as if someone had cut the head through the brain horizontally, and we're looking down, and here are the eyes, and this would be the occipital lobe, okay, the visual cortices, the left side here and the right side there. All right. Now, we all know about decussation. We all know that central nerves from the right brain go to the left side of the body, from the left side of the brain go to the right side of the body. And so we would expect to find something very similar in vision, but we don't find it exactly that way. There's a very significant difference. Let's ignore these black bars right now. We'll come back to them later. But let's just look at the red and the blue. So we're going to start in the blue, which is the left visual cortex, the occipital lobe. And we have the optic nerve coming from here. I just lost my, whoops, not what I wanted to do. Okay, sorry. There we go. I had lost the cursor. We would like to think it would just go there. But it doesn't. It goes to this central place, which is called the optic chiasm. And it splits into two. And again, just follow the blue. Half of it actually does continue to the right eye, which is what we thought all of it might do. But half of it makes a left turn and goes to the left eye. Now let's go to the right visual cortex, the occipital lobe. And that also comes to the optic chiasm, and it too surprises us. And half of it goes to the left eye, and half of it goes to the right eye. So we already have something that's different and unexpected, and complicates, but not completely. We're going to get a little bit more complicated. What do we see? So again, let's follow the blue. So the left optic nerve goes to the optic chiasm, moves up to the left eye on the left side. Again, this is the back part of the eyeball. Okay? That's the front that you would see. If you look at someone and you see their eye, you would see this part. This is behind the eye. And so the left optic nerve is on the left back part of the eye. The right optic nerve, which goes this way, is behind the right side of the left optic eye. Okay? So we actually have representation from both the left and the right visual cortex in the left eye. The left, again, in the posterior part, the back part of it, the left is on the left, the right is on the right. That all makes sense. If we do the opposite, as you would expect, it's exactly the opposite. So now the left goes to the optic chiasm, stays going to the right, and it's on the left side of the right eye, and this that splits is on the right side of the right eye. Okay, so almost okay, right? But now let's make it more complicated. What does that see? Remember, when we see, we don't see with the, we see with the nerves, right? Just like we hear with nerves, with the auditory nerve. The ear is just a channel, and the eye is just a channel for the visual. Okay, we actually interpret and see with the nerves, the optic nerves. Well, the part that's on the left side of the left eye actually sees the right side of the visual field. This is called a visual field. This is what we see. So the left side of the left eye sees the right side. The right side of the left eye sees the left side. So we actually have almost a triple cross, right? Certainly a double cross. It goes here and it splits, and then it goes here and it goes the opposite way. It goes here, goes that way, goes here, goes that way. Okay, I'm going to show this to you in different fashions as well. Let's get some terminology though. Okay, the terminology is we're going to try to drop left and right, because if we'd have to talk about the left side of the right eye and the left visual field of the right side on the left, we'd be very confused. And so actually medically we don't use those terms. What we'll talk about in terms of visual fields, this visual field, now remember this is superimposed. Let's imagine there's a skull around here. So what's here? This is the left side of the head, because we're looking down. This is the right side of the head. What's on the outside of the head? Well, the temporal bone and the temporal lobes, right? So when we talk about this side or this side, we talk about temporal sides, the outsides. When we talk about in here, whether it's this part of the visual field or that, anything that's like between the eyes, we talk about it as the nasal side. So we have a temporal side, which is on the outside. We have a nasal side, which is on the inside. Okay. Now let's go back to the black parts. Okay. What the black parts are telling us here is what happens if there's a lesion, or if there's damage. Okay. So let's look at the damage. There's really no difference between 4 and 5, and I've never been clear why that's there, why both of them are there. But let's look at 4 then as the example. 4 is saying that the left optic nerve is severed right here. So let's see what happens at 4. If we're looking at the visual fields now, what we're saying is, well, we have that visual field and that visual field. Both of them are the reds, meaning that they came from the right side, and those are okay. So we have the left temporal and the right nasal are fine. What about the left nasal and the right temporal, that or the blue coming from here? Well, they're blocked out. And so that if a person who has that sees something in front of them, what they'll see is, and again, let's say they're looking at a line, they'll see the line and then they won't, and then they'll see it and then they won't. It'll be blocked out in certain places. The same thing would happen, obviously, on the right side. They don't show that because it's exactly the same thing flip side. Okay. Let's look, though, well, okay, no, let's just stay with that, all right? Let's just stay with that for right now. Okay, we're going to look at another diagram. This is actually, again, it's just a totally, I'm giving this to you, I'm going to give you 3, I think, to show you what it looks like. I'm not going to belabor this. It's exactly the same information as before, it's just a different artist and showing you a different way of doing it. Okay, and you can study this and you can look at it. Okay, and again, it's in your book and it's explained there as well. And one more. Okay. I want to look at number 5 here, though. Number 5 is actually the same thing as that number 4 that we saw before, with where the left optic nerve is severed here. And that's number 5. And what do we see? We see that this is okay and this is not, and this is okay and this is not. And that actually has a name. That name is called right homonymous. I'll show you that word. It's in the slide that we had before. It's over here. Here they happen to show you left, homonymous, hemianopsia. That word is over here. Here's an example of left homonymous hemianopsia. What this is right homonymous hemianopsia, where the right side of each side, the right visual field of each eye is blacked out. Why are we belaboring this one? Because that can happen to a person with aphasia. These nerves are running right through the brain. It's on the left side, which is where damage for aphasia will be. It's in the posterior part. This is probably around the temporoparietal area. And so a person with that kind of aphasia might have visual field deficits. I said before that, like, it would be like if you looked at a line, yes and then no, and then yes and then no. Fact is, eyes move, right? When we look at something, we don't stare right ahead. Our eyes move. The person doesn't perceive that they're not seeing here because the eyes will compensate. There'll be some lateral movement. That's the part that they may not see. And that when you put a line of text in front of a patient with aphasia who has right homonymous hemianopsia and ask them to read the line, and let's assume that there are 6 words on that line, and he's capable of reading, he might read word 1, 2, 3, 4, 5 probably, and number 6, he doesn't know that it's there, and so he just goes to the next line. As far as he knows, the word's not there. If he's intact linguistically, he's going to go, well, this is not making sense. But he's aphasic, and so he may not realize that it's not making sense. On the other hand, you may put out, you're doing therapy with the patient, you put out pictures for him to point to, and you put out 5 or 6 pictures on a table from left to right, and you ask him to point to one of them, and it happens to be on the right side. It's number 6. And he doesn't get it right. And you go, gee, I wonder why I didn't get that one right. It's not any harder than number 3 was, but it's where he can't see it. Okay, we're going to come back to this point a number of times. Try to absorb it. Try to understand that potentially the right visual field may not be available to our patient. Okay, another topic that has to do with brain and may have some relationship to aphasia is handedness. We know that most people are right-handed. Almost everybody is. Maybe 90% or something like that. I don't really have an exact number. But I do know that almost all people who are right-handed are left dominant for speech. Okay, very few people, when it comes down to it, are right dominant for speech. Even in left-handed people, and it may vary whether or not there is strong genetic history for their left-handedness or not, or whether they're like the first ones ever. So someone, I don't, usually at this point in a class when I'm teaching live, I would say, how many of you are left-handed? You could tell me that maybe in your blackboard, and I may ask you that question. But then, who else is left-handed in your family? Are you the only one, or do you also have a sibling and a parent or a grandparent or an aunt and uncle, blood relation, who is also? Which would make it more likely that you might be right hemisphere dominant for speech and language, or at least both bilaterally dominant. That you have language actually in both hemispheres. The difference would be only, and let's hope you never find this out, is that if a person who is left-handed had a stroke, if their stroke is in the left hemisphere, then the odds are they're probably aphasic, because again, most of them still have language in the left hemisphere, but some of them may have some language in the right hemisphere, in which case their language may not be as impaired. Okay, so it's something to know about, something to think about. We don't have that many left-handed aphasics. I don't know that anyone has ever done a study on left-handed aphasics versus right-handed aphasics. And we don't really know if a person is left or right dominant for language unless we did very specific testing, which we don't typically do. So, but it's of note. It's of interest, something to think about. Kind of put it in your pipe, right? Okay, gender studies. So I have to tell you something quickly about gender studies. We don't really have that much. You know what? I'm going to stop this. We'll have one more quick take.